So in this video we will try to see that this function, which is a two variable function, scalar function, whether it is continuous at origin or not. So the function is defined partwise. So at origin it is 0, and other than that it is basically xy square by x square plus y power 4. Now it is continuous at origin if the limit at origin exists and the value is same as the value at the origin. So if it is continuous, then we have to show that xy tending to a comma b. Suppose I am checking the continuity at a comma b. So if limit of the function at a comma b is same as f a comma b, so then we can say that f is continuous. So at first we have to check whether the limit exists at the origin or not. So what happens if we approach via x-axis? That means if y equal to 0. So this is my x-axis. So if y equal to 0, we can see the functional value is 0. So limit of xy tending to 0 comma 0, that origin, this fxy is basically 0. But when we see along the y-axis, then our x is 0, and in that case also this limiting value we can check that this is 0, because the function value is 0 when x is 0, as you can see, and as y approaches to 0 we are getting closer to 0. So does it imply that it is continuous? No, right? Because we have only checked for two straight line. Now if we check for any arbitrary straight line y equal to mx, let us see what happens. For y equal to mx, if we substitute this, then our fxy is nothing but x mx square m square x square by x square plus m power 4 x power 4. So it is m square x cube by x square plus m power 4 x power 4. So this x square got cancelled out from both denominator and numerator. So I am getting m square x 1 plus m power 4 x square. So as xy tending to 0 comma 0, that is we are tending to origin along this straight line, then limit fxy as x comma y both tending to 0 comma 0, this is nothing but limit x tending to 0, this function which we have got, m square x plus 1 plus m power 4 x square. So let me separate this out. Yeah. So as x tending to 0, the value of this function is 0. So along any straight line we are seeing that this function is going towards 0, but still we cannot conclude that this function is going towards 0, because there are infinitely many curves by which we can approach origin. So is there any curve by which we are getting any other limiting value? So let us try one curve, that is y equal to x equal to y square. Let us try this curve. Now for this curve, now as xy tending to origin, that is 0 comma 0, so this is my fxy. So let us write the functional value here. So our functional value was given to be xy square by x square plus y power 4. This was given. So now I am approaching through the curve x equal to y square. So I am just writing xy tending to 0 comma 0. Now x equal to y square, that means in the numerator I get x square, and in the denominator I get x square plus x square. So this is nothing but limit x tending to 0, x square by 2x square. So I am getting half. So this limiting value is half, which is not 0. So when we are approaching via any straight line, we have seen the limiting value is 0. But when we are taking this curve, so this is a parabola. So when we are approaching via this parabola, we can see that the limiting value is half. So the limiting value does not matches for any curve. So we can conclude that the limit of this function does not exist. So limit x comma y tending to 0 comma 0 fxy does not exist. So that means it is not. So fxy is not continuous at the origin. Thank you.